This is going to be a long one, so I'm going to skip the introduction and get started right away. Today we're going to be doing pretty much everything with enemies. We're going to be doing enemy pathfinding, enemy attacking, and yeah, it's going to be a lot. So to start, let's talk about the general basis of how this system is going to work. To get enemy pathfinding to work properly, we need to make sure that each enemy can move individually. The reason for that is because we need to make sure that enemies are able to move individually to calculate their collisions and paths without other things moving at the same time. Because if you have everything moving at once, it will be faster, but it'll be totally chaotic and things could end up in the exact same position as each other. So in order to make this work, we'll need to make a queue system which systematically adds enemy IDs to a queue and then goes through in order, indicating from the top, this enemy can move, then once that enemy is moved, it goes to the next ID in the queue, tells that enemy it can move, then it continues until the queue has been completely emptied, and then once it's emptied, then the player is told it can move again. So it's a cycle. Once the player moves, it fills up the queue gets emptied as enemies slowly move, then once the queue is emptied completely, then the player can move again. So let's start by doing some general stuff. We're going to need to go into the enemy and start adding some new variables. These should be kind of familiar. M speed is the same as usual. It's the speed that it takes the enemy to progress per like pixel steps, I guess. Path is going to be just a general variable that we're going to use to store our path that's going to be created using the GameMaker pathing system, which is actually a lot better than I used to think it was. It's pretty cool, actually. Target, this is just how the enemy is targeting. It's going to go for the OBJ player. If you want to, I guess, to have multiple characters, then you could have a targeting system. This would be how that would work. Moving just indicates whether the enemy is currently moving or not, so it's currently in its pathing process. Can move just means it can move, and then we'll switch from can move to being true to moving to be true, and then can move to be false. When can move is true, that's what the queue is setting. So the queue will set the enemy's can move to true. The enemy will check, will create its path and then switch can move to off and moving to true, and then until moving is false, then it won't. Once the path has been completed, I guess, it'll set moving to 0 or to false, and then go to the next enemy in the queue. Okay, so now let's also add to our destroy here, just to keep things good. Let's also go back into the controller and make some modifications. We're going to create some stuff down here in the enemy section. We're going to create an enemy queue, like I've been talking about. It's going to be a DS list. Technically there is a DS queue. I don't use it. I don't know. I feel like the list is just good enough for what I need. We're also going to be creating a MP grid, which, if you're not familiar, I'll pull up the manual. An MP grid, well, this isn't great. Motion planning is what it is. So MP stands for motion planning. It's what it sounds like. I don't know why I opened the manual. There's no point. It's what it is. It's motion planning. So basically this grid will be another grid that'll exist on top of our DS grid, our OBJ controller.grid. And this one will specifically be used to do the pathing. And we'll use our grid already created for collisions to help fill in our enemy grid when we need to. So we first need to fill out a bunch of stuff. So left, top, those are like the top left corner of the grid. Mine is set to 0, 0. If you want to do a shifted grid so you can have some UI space, I mean, I recommend that. You'd have to make some modifications for this tutorial though. I'm not planning around moving the grid, I guess, at the moment. So I think that's something that you can figure out yourself though. And then H cells and V cells, these are just how many cells or how many tiles there are for the characters to move. In this case, it's 10 by 10. And then the last thing, cell height and cell width, we know what that is. It's 20 by 20 because we're using squares, so we use the same variable, which is dim. Okay, so that's all. We have these two things now. The queue is going to be used to load up our enemies, and then the enemy grid, each one is going to use on its own to create its path. So now we're also going to go into game end here and free up some other stuff. It's always good to do this because if you don't do this, it could cause memory leaks. What am I doing? Yeah. Okay, so now let's start. I'm going to do this in a different order. Let's start out actually by going into the player alarm. This is going to need to change. So this is actually what's going to calculate our what am I saying? Our enemy queue. Once the enemy is done moving and it's out of moves, then the queue is going to start getting filled up. Before we do that, we actually need to fill in some new variables. Probably should change that. We're going to do max moves equals 1, moves equals max moves. And we'll also throw in HP. So max moves is just going to be how many movements you can make before the next enemy queue, the next enemy wave of attacks happens. And the moves is just going to be like just how many moves you have left currently. So the max moves is going to be it's not going to be a constant. You'll be able to modify it, but moves is going to be the usual stuff that we're going to touch. So now let's go back into alarm 0. We need to make it so that when the enemy is out of moves, the queue gets filled up, and the enemy can't move until the queue is completely done. So we're going to do some kind of weird things to this code. We're going to set this to check if moves are 0, then moves are going to be set to max moves, just to anticipate. And then it's going to do this weird thing. So queue enemies is going to be another new script. Queue enemies, we'll do that in a second here, is literally just going to do what it sounds like. It's going to queue up the enemies, but it's also going to be a true-false statement. So if there are any enemies existing, then it will return true. Otherwise, it will return false. So we're going to end up using this to make it so that enemies can be repopulated. So if this returns false, then we'll be able to make it so enemies will get respawned. But we're not going to do that here. And the reason is because we want to make it so the enemies get respawned when the player is ready to move again. So we're actually going to do that down here. It's going to look kind of redundant, but it's just how it needs to be. Wait, I've gotten confused. So that's here. Yes. Okay. So the reason why this is set up like this is because of how the player moves and attacks. So when the player moves, it's going to move, and then it's going to check if moves are equal to 0. We haven't done anything that makes moves, well, let's do that now, just before I forget. If the player attacks, moves are going to be set to 0, because you're only going to be able to do one attack per volley. because there's going to be a damage component. So when you're done, when you move and you're stopped, it checks if there are any moves. If, regardless of whether there's any moves left or not, it's going to set alarm 0 to 10 so that it creates that buffer, so you can't just constantly move rapid fire from one to the next. There has to be a pause. However, if your moves are equal to 0, then it's going to go ahead and make your moves equal to max, and then it's going to do, like, even though this says not, don't get confused, this is still going to trigger regardless, so it's going to queue the enemies up, but it's still going to do alarm 0 equal to 10. Yeah. I'm reading this and it's like not making sense to me now even. I'm realizing this happens twice. This can happen twice, because if you are out of moves, it'll happen, then it goes to alarm 10. It happens again, but moves aren't equal to 0 anymore. Never mind, no, it works. Because if you move, you stop. Moves get equal to max moves to prevent this from happening. So the queue happens once, then next time it'll set it to 0. Can move will be equal to true. By that point, the enemies will be queued up again. And I am missing something in this, actually. What am I missing? Oh, yes, okay. So here's where we're going to do populate again. So this is if there are no more enemies, then here's where we'll populate. We'll populate when the enemy is ready to move again. So there we go. Now it's time to actually make that queue function. Queue enemies. Oops. So we're first going to check if the parent enemy exists, or if any enemies exist. And then if they don't, return false. But if it does, return true. There's more to it than that. I'm just doing that first. So now let's start declaring some temporary variables. We're going to need to, so for this queue, we're going to run through all of the different enemies in the game and add them to the queue one by one. So to do that, we're going to need to do a for loop. And we're going to do it equal to the number of enemies in the game. And then we're going to set this enemy equal to just an enemy. So this enemy equals instance find thing is a really, really good way of just finding all instances of an enemy that exist. Because since instance find just looks for the number, just this weird number of enemy, and it's based on when the enemy was created. So the first enemy that will get created will have an instance find of 0, and then all others will be 1, 2, 3, however many there are. So this will find them all, and it will register them in this enemy variable, and then it will place the enemy variable into the enemy queue, like so. Lastly, we then need to make it so the enemy can actually start moving. So once the queue is done, we look at the top enemy in the queue, and we set it to move. So there we go. So now the first enemy can move, but it doesn't know what to do with that yet, so we need to make it move. So let's get into parent step. We should probably save. I don't even know how to, we're just doing that. This is going to be the bulk. So here we go. First things first, if can move. Nothing will happen if the enemy can't move. So we're first going to actually check if the player or the target is adjacent to the enemy it's going to attack it immediately and then ignore everything else. So as soon as it attacks it, it's going to set can move to 0, and it's going to move to the next enemy, because that'll be the end. Enemies will only be able to attack once, just like the player. So for that, we're going to write some pretty long code here. We're going to check the collision at all the different locations. And we're checking for 1 because 1 is player, if you recall. I'm going to full screen this because this is going to be long. So now we're going to check down. And then left. And then up. So if there is an enemy there, or there is a player there, then we're going to set target HP minus equals damage. And that's the damage of the enemy. So the enemy is dealing damage to the player. And we're going to immediately set moves equal to 1. So even if the enemy has another action it can take, it's not going to matter. It's just going to be done. Because once we create the alarm 0, I don't remember if we did that already, I'm assuming no, it's just going to set it to moves minus minus. So it's going to be equal to 0 and then immediately be done. So this might as well say, this sort of says 0, not exactly. So that's that. That's attacking right there. We did it. Congratulations. Okay. Now for the fun pathfinding stuff. So if you remember earlier, I talked about the MP grid, the motion planning grid. So first things first, since we're going to be doing individual-based pathfinding, so every time an enemy is prepared to move, it's going to need to calculate its own path individually. So since we're doing that, we're going to need to make it so that the grid just gets cleared every single time. So we're going to do clear, So it's going to clear the enemy grid, and then we're going to start declaring some variables to prepare to create the new grid based on where the enemies are located. The reason why we need to do this calculation every single time is because imagine if the first enemy moves, it calculates its grid, has all the locations, then it itself moves into a new location. Now when the next enemy is ready to make its new path for pathfinding, it can't use the same grid that the last enemy used, because now the last enemy is in a different location, so the grid is completely different. So it would end up being a big mess if we didn't recreate the grid every single time. So there might be a better way to do this, but this is the way I'm doing it. So there. So you know how this goes. We're doing the nested for loop again. It's okay. I like nested for loops. Okay. Now we're going to check, well, we're not going to check anything, we're just going to get, well, no, sorry, we are going to check something. What we're doing right now is we're checking for all obstacles. So it's literally anything that isn't empty. And we're going to add the non-empty things to the MP grid so that those are obstacles for the pathfinding algorithm to look for and move around, basically. Okay, so what this is doing is it's clear previous grid, then fill the blank grid with any and all obstacles. Okay. So now that we've done that, there's some other things we need to do to prepare. We need to make it so the enemy's current location and the player's current location are not considered obstacles. The reason is because the way that this pathfinding algorithm works is it just doesn't like it if its own self or its target self is occupied. So we just have to do this. Oh, we should do target. What have I done? Oh, there we go. So that's clearing the player cell. Then we're gonna clear the current enemy's cell. We don't want to clear the other enemies because we want to make sure we avoid those. So and remember, c.enemy grid is the motion planning grid, not the normal c.grid. And also remember gx, gy, those were already set in our create right here. So this is our grid component. So that's based on the grid we have created already from the, that is normal grid components, but it works in the same way because we have them overlapped correctly. So the last thing we're going to do is update the path, or well, I'll say refresh the path. And all that I mean is might seem silly, but I don't know, man. I'm doing it. So now it's finally time. We have the path ready. Well, sort of. We need to create the path and immediately test to see whether it's a valid path that can be completed. So to do that, we do this MP grid path, which has a bunch of different things. The ID is going to be the ID of the MP grid, which is c.enemy grid, or objcontroller.enemy grid. The path is path, we already have that created. With the x start is x and y, the current xy pixel coordinates of our enemy. The goal is target.x, target.y, and no diagonals, no. Now, if that is considered, so this is this literally creates the path and it returns whether it's valid or not. So if it's valid, then we can path start with path, and we will be moving at m speed, which is 5. I made it a little bit faster than the player just because it gets a bit slow. And this just determines what happens when the path is reached its destination. In our case, it'll be path action stop. It doesn't actually matter though, because we're going to stop it ourselves. An absolute, I don't actually remember what that does. I'm pretty sure that means, I don't know, it doesn't matter. Here, I'll look it up, because it does matter actually. No, not that. What am I doing? Grid, path start. Whether the calling instance should follow the absolute path as it is in the editor, true, or a relative path to its current position, false. Yeah, we want relative. Absolute, I think, is if you use the path editor, which, you know, we're not doing that. We're doing code paths. Yes, where were we? We're here. So now that we've done that, the path is starting. So the player is, or the enemy is moving. This is as if we are moving we have set the H speed and V speed, sort of like when the player moves. So now, similar to what we did with the player, we need to make it so the grid is set to be 0 now, because the enemy is no longer occupying this space. And keep in mind, we do not have anything that's constantly modifying the enemy's GX and GY. It pretty much only happens when we want it to. And I don't know, I've just found that to be the best method of doing it. I think you could do it the other way, but I'm not. And this is exactly the same thing that I was doing earlier. So like I said, we're not going to be letting the path stop itself, because we don't want the enemy to just go halfway across the map and attack the player. We want it to move in tile increments, and only as many moves as we give it. So if you remember max moves and moves, that was a variable we gave the enemy. So it will only be able to move so many tiles, as many as it has moves, basically. So that's that. It's moving now. But if the path does not, so here, so, right, we don't need to do that. All I'm saying here is if the path is not completable, then just skip it. Don't bother starting it. Don't change anything. Just make it so it goes to the next enemy. In alarm 0, this will be what triggers the stopping of the enemy and the moving on to the next queue. Or if it still has moves left, then it'll continue to do this again and it'll just reset can't move. So, speaking of which, can't move is going to be false because either way, something is happening and moving is true. Even if it's not, we're just going to make it true because that makes it the most easy. And hey, we're done with that. We still aren't done though. We have to do the alarm now to make it so this thing can actually be stopped. So first things first, path end. We're also going to do moves minus minus, and moving equals false. So this is triggering after the path has been, well, not the path hasn't been completed necessarily, but the enemy has moved a full tile and not hit an enemy. So it's checking up to see if it still has enough moves to continue with the path, or to, if it doesn't, then it will, it'll stop moving completely and move on to the next enemy. So we're also going to just manually update this stuff because now it's in a new location. And we're going to go ahead and set it for the player. Or not the player, the controller. What have I done wrong? Yes. So now, if the player, or the enemy, is out of moves, then we're going to set moves to max moves so that it can be ready to move again when it's ready. We're going to go ahead and delete our instance of the queue here. So remember that we're still on this same enemy's queue. We never deleted the queue, this enemy's, position in the queue. So it's still available. So now we're going to delete it so that next time we reference the queue, it'll be looking at the next enemy correctly. And we're going to go ahead and check to see if the queue is now empty. And if it is, then we're going to make it so the the player can move again. And then it'll complete the cycle effectively. And remember, target is the player. So, actually, let's do this. This just looks nicer. So what I'm doing now is I'm saying if the queue is not empty, then go ahead and select the next enemy to move. And it's worth mentioning that we did have if moves equal 0. So if moves are not equal to 0, then we just ignore all of this and let the enemy move again. So yeah, nifty. But the enemy still is losing 1 move, so it only has so many. So yeah, I think that might be it. I think that's it. Let's test it, I guess. All right, so, oh, what did I misspell? Grid height not set. Oh, did I didn't put C there. Where is that? That's line 17 of step. Okay. We can fix that. C dot. Okay, let's try again. Close. Enemy 1 moves not set. I definitely thought I did though. No, I didn't. Or did I not set? What did I not set? I thought I did that. What's in parent enemy? Okay. Let's do that. I think that should work. So it'll set max moves to 1, and then it'll inherit the event, which will then set moves equal to max moves. I think that that's good. And work. That seems promising. Nope, I didn't do damage either. I'm not good at this. Okay, last but not least, let's also do this for the player so that we can actually see the HP being lost. And you know what? Let's make max moves for the player equal to 2 just to make it a bit more fair, and hopefully we'll be able to test this and see if it works. I'm hoping it works. So yep, I can move again for free. And I can attack, and that costs a move, and then I lost HP. Lost 2 HP. I'm getting hurt. So I can move away, move and attack, 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 attack. Oh, just not good enough. Oh, yes, I'm good enough. Ah, nice. And last but not least, after attacking the last enemy, it refreshed the enemy. It repopulated is what I'm trying to say. So to end off here, we will take a look at the grid. Looks lovely. It's all working properly. Can't see HP here, so it's kind of hard mode. But yeah, that seems good to me. In the next episode, the final episode, we'll be finishing up things by adding enemy variants and also adding randomly spawning enemies or randomly spawning items that will give you power-ups. So it'll be pretty. Also, I'll add some basic progression that makes it so more enemies spawn over time. It'll be the shorter one, just a nice little closer. Hopefully you've enjoyed these, and hopefully this wasn't too long. Thanks for watching, and hopefully I'll see you for when we finish up.